Do you think building an undersea tunnel is as simple as drilling a vertical shaft under the sea and then digging horizontally? That's still a bit too simplistic. Let me explain how an undersea tunnel is actually constructed and why seawater doesn't flood in. 30 years ago, the UK and France jointly built the Channel Tunnel. How did these two old European rivals end up working together? It turns out that the English Channel is located in the northwest of Europe, connecting the North Sea with the Atlantic Ocean, and is the main waterway separating the UK from the European continent. The channel's geographical position is extremely important, serving not only as a crucial maritime trade route, but also as a key area for military defense. Historically, interactions between the UK and France largely relied on ferryboats, which were not only time-consuming but also heavily affected by weather conditions. Especially during adverse weather, ferry services were often disrupted, severely impacting maritime trade between the two countries. Perhaps to ensure that the next Dunkirk evacuation could be swifter, the UK and France indeed came together to jointly construct this tunnel. According to the plan, the design of the English Channel Tunnel, the total length exceeds over 50 kilometers, with 38 kilometers buried under the sea. To save construction time, the UK and France decided to start construction simultaneously from their respective territories, advancing towards the center and then meeting. They planned to build 3 tunnels at once, 2 main tunnels for train passage and 1 service tunnel. The beginning is always the hardest part. What machines should be used and how to prevent seawater from flooding in? British and French engineers chose a tunnel boring machine known as a shield machine, a miraculous tool for tunnel excavation. This equipment is equipped with sharp cutting heads at the front, capable of digging through rocks and soil as easily as cutting through tofu. The excavated soil and rocks are transported to the rear through pipelines and then carried away by transport vehicles, making the entire process both efficient and precise. Moreover, both countries started digging on land, each creating a vertical shaft, and then horizontally tunneling through the English Channel. According to the initial design concept by the planners, the entire project includes a 38-kilometer tunnel running under the seabed, which is completely sealed, so there is no need to worry about seawater seeping into the tunnel during construction. However, plans couldn't keep up with changes. While excavating the undersea tunnel, engineers discovered some fissures in the seabed marl which could allow seawater to seep in, threatening the safety of the tunnel construction. Facing this challenge, the engineers quickly adjusted their strategy. Instead of immediately transporting the excavated soil away, they added a storage area behind the shield machine's blades, then mixed part of the soil with water in a certain ratio to form a slurry layer. Under the pressure of the shield machine advancing forward, this slurry was injected into the fissures of the tunnel. This method effectively blocked the continued seepage of seawater. As the shield machine kept advancing, the length of the tunnel also kept increasing. However, a new challenge emerged before the engineers. Once the tunnel was excavated, the rear sections, lacking support, could potentially collapse. To address this issue, engineers used prefabricated concrete for reinforcement. These concrete blocks were lifted by jacks inside the shield machine and assembled piece by piece to form a sturdy arched support system. In this way, even if the rear sections of the tunnel lost the support of the soil, they would not collapse. After years of hard work, the UK and France